The following data corresponds to the number of hours various employees had spent on a training problem and their performance on a subsequent assessment out of 100. So we have all of the data just here. Display the data on the scatter plot below. So the first one is going to be 266. So 2 and 66 would be here. And then the next one is 3.561. 3.561 would be just here. And I'm going to pause and put the rest of the data on. So the first thing we're asked to do is calculate R for this data. So that means bringing in the calculator again and calculating the value of R. So let's grab our calculator and let's go back to here. And what we need to do is clear the table. So I think I need to exit one more step and again and again and delete all. And I think that's just going to, so yes, F1 just clears that list. So I have to go into the second list and delete all the things in that list. Yes. Go back to this list and put in the values. So the X list is going to be the 2, the 3.5, and so on. I'm going to pause again and put all the values in. Okay, so we've got all the data in, and then we want to calculate. And in the previous example, we did the set, but I haven't changed it since. My X's are in list 1, my Y's are in list 2, so I'm just going to go straight to regression, and it is X. There's lots of other types of regression, but we're only doing linear, which is the X one. And we want AX plus B. And so a lot of the things we need for this question are here on this screen. So we've got R is equal to 0.844. So I'm going to say 0.844, which is a strong correlation. Describe the relationship between the hours studied and the performance on the assessment. I usually like to say two things here. I like to say that we have a strong positive correlation, but I also like to say something in context. More hours of training lead to a better result. State the equation of the least squares regression line in the form P equals AH plus B. So the P being the performance. And then we go back to the calculator and we have the A, 3.761. And the B was 51.049. So 51.049. And these have a meaning which we're not actually asked about here, but this indicates that every hour of training is going to increase your performance by 3.761. And this should correspond to doing no training, the mark you would get with no training. Add the line to the graph above. So what we want to do is draw this line of best fit on the graph. So to do that, let's think about H is 0, P is 51.049. So it would be about here on our graph. And if we substitute H equals 10 and calculate, we get that P is 88.659. So that is going to be about there on our graph. And so we can do a straight line that goes through those like so. So that is our line added to the graph. Interpret the gradient and the y-intercept in the context of the question. We've actually already did that. We talked about with the gradient 3.761. That means for every 1 hour extra training that you do, your mark would increase by 3.761. And for the y-intercept, no training would lead to 51.049. But as we'll see, this value is in question on this graph. Just have a quick look at where the data is and where that intercept is, because that leads us on to the next section.